All right, well, I think we're all here, so let's get started. I'm recording this so Phil can watch it later, but let's get going. So it's been about a year since I presented this last, and surprisingly, not a lot has changed. I kind of expected that what I was looking at then was kind of a beta. I had no idea it was going to be released so soon, but it hasn't changed a whole lot. There's a little bit of changes, and I'll note some of those, but it's pretty cool. One of the big changes, though, for the benefit is that it's ready to go. So let's talk about it, and then let's see about using it. So what I start off with here is what is WebAssembly? So WebAssembly is a machine agnostic kind of intermediate language. So think of like the .NET CLR language or Java bytecode or LLVM's intermediate language. In fact, I believe it follows very closely LLVM's kind of pattern. It's native speed. It's sandbox, the same as JavaScript. And another cool thing is it doesn't matter what you build these libraries in, because they all compile down to this intermediate language. They should all be interoperable. So we can call this stuff from JavaScript. We can call it from our other WASM modules. We can manipulate the DOM from our modules. We can have JavaScript call into our modules. We can call into it. So whatever we need, we can all do that. So it's kind of a great little interop story. And if you're kind of curious what it looks like, here's a kind of a simple function written in C. And then you get kind of this intermediate language in the center. Oh my.
You're not screen sharing.
I'm not screen sharing. Let me back up a bit then. Share my screen. That's a wonderful idea. Well, I'm off to a great start. Let's try this again. So, about WebAssembly. Okay. Okay. So here's what it looks like. So on the left here, you see kind of a C input, a simple factorial function. In the center is what a text representation of that intermediate representation looks like. If you've ever worked with LLVM before, you'll see it looks almost identical to LLVM. And then on the right is the byte codes. So once it's actually compiled, that's what it looks like. It should be worth noting that I believe that the browser can take the text representation or the intermediate representation and compile it for you. But typically when we compile it, we compile it down to the binary. Okay, so if you're interested in doing this in C++, this is essentially what it would look like. You have this basically small, tiny, do-nothing program in C++, but there's now this WebAssembly equals 1 flag you can add. And then you can say I want to output hello to HTML, and it outputs WebAssembly. This is what it'll output. So in your, if you were going to make this program, what it's really interpreting it as is this. And if you wanted to call that module from JavaScript, all you need is, let's see, where's my pointer? So all you need to do is do a module.ccall. My function is the name of the function we want to call. It's right here. And we can have return types. We can have arguments, types and arguments all kind of baked in here. We're not passing anything to it, so it just gets called. In C#, it's a similar kind of thing. So if we had just a tiny little function here that does almost exactly the same thing, we could compile it like this, and then we'd want to convert it to WebAssembly and get an output. And if you wanted more information on that, there's this link here. But that's all kind of complicated. Enter Blazor. So it's a framework for creating this stuff a lot more easily with C#. It's full stack based on .NET Standard currently. More on that later. It runs in the browser, takes advantage of WebAssembly, uses Razor type syntax for the front end UI. It's open source, it's free, it's simple, it's productive. It is really kind of great. We'll see, and you'll see it. So why is it really cool? It helps us to easily offline complex applications. So one of the things you can do is reuse some of your classes. Maybe you want put some validation attributes on a class. You can validate it on the client side and then use that same class on the server side and do the same validation that happens on both sides. If there's validation or any kind of thing that would make sense to have in both the browser and on the server side, it's just easy. You can just reuse those components. Another cool thing about it is if we're running an old browser, it will fall back to using a JavaScript runtime, which basically interprets the WebAssembly. So there's a polyfill for it. It's got full garbage collection and threading support, and I say full threading support. It's mostly full threading support. Full threading support's coming. It allows us to make components. So just like in Vue or Angular or React, you can create these components that are reusable, not just in the project but elsewhere. I think it helps kind of with some unit testing stories, and it supports any .NET Standard 2.0 or higher modules. If something is in there that it doesn't support, so there's some things that aren't going to make sense for the client-side browser, those things have been explicitly called out or forbidden. You'll get a platform not exported exception, but typically anything that makes sense to run in the browser will actually just run in the browser. Another cool thing is the server-side rendering. So this is less common these days, I think, maybe, but it used to be a real neat trick to server-side render a component and then pass that up to the browser, and then on the client side you can kind of recapture that component. So like if you have a React component that emits this bit of HTML, when the page refreshes, you can actually push that exact HTML that it emits up to the client for SEO purposes or speed purposes or both. And then later when the React component finishes loading, it'll just kind of take control of that rendered component, and so it can function beyond there. We've done that a couple times. It says relatively small footprint. I have not updated these slides, but you're going to be amazed about the size of the footprint of this thing. It is not even anywhere near 800 kilobytes. And even on the server-side render stuff, it's not even near 50 kilobytes. So it's kind of cool. What are some downsides? I'm going to strike this one. This is no longer a downside. The size of the runtime is smaller than most images that you would include. It currently is still JIT compiled, and full AOT is on the way, but currently what happens is it kind of pulls in this runtime that's kind of a JIT compiler, and then any assembly that you reference gets downloaded to the browser and then JIT compiled from there. That's only going to be a temporary story, but it doesn't matter. It's still plenty fast. We did mention before, there's a lot of things that can be, or sorry, we're sandbox still. So what I have here, and I'm not going to click it because I'm trying to do this a little bit quicker, but this is Windows running in JavaScript. So if you're interested in that, one of these times you can actually click on that and it'll show you. It's pretty neat.
Copy that and paste it into Slack or something.
Okay, we'll do it later.
Okay.
Okay, so what can it do? Well, it does components like I mentioned, routing, layouts, form validation, dependency injection, JavaScript interop. What doesn't it do, right? It does live reloading. That is, if you make some changes here, it just kind of automatically appears on the other side. Server-side rendering, and we'll get more into some of that. Full debugging support, IntelliSense and tooling, and publishing app size trimming. So they got what's called tree shaking. They got that algorithm in and on this version. So you're only going to include the bits of the runtime and the libraries that you actually use. rather than the entire thing. Okay, in order to get going, you need Core 3.1.3, but it's really intended to run on .NET 5. So you can use it right now on 3.1.3 and later upgrade it to .NET 5, which is supposed to be a very easy conversion. But if you want the long-term support, it's going to be on .NET 5, not .NET 3. Sorry, not Core 3. And it's, again, compatible with anything that's .NET Standard. However, again, with .NET 5, there's no longer a need for the standard nomenclature. So everything's standard because it's kind of just one unified platform at that point. So I think I'm excited for .NET 5. The runtime is significantly smaller. So like I mentioned in the previous slide, it was about 800 kilobytes before. It's now less than 60. Just kind of for some perspective, this 60 kilobyte runtime is 1/3 the size of bootstrap.min.css. So that's kind of cool. There's already a bunch of third-party components. I was surprised to see it in the the launch post, and I went and looked at them. There are a bunch of third-party UI components, both paid and free. The paid ones, of course, are by the people we normally would expect to see paid components by. But there's also a lot of free ones. So in Blazor, there's a couple of ones that are interesting, like the modal and the toast and the menu. Blazor A's has some components that are built on Bootstrap and Material, etc. So the point behind those is they're more like HTML components, but a lot of the style and stuff is just kind of automatically added. Blazor Extensions, though, has a lot of very interesting components. There's also another one, Ant Components, that has a lot of interesting things, although something about their site kind of made me want to stay away, so I didn't mention them in my slide. But there's lots of cool stuff already. What's next? Well, there's still some things to go. AOT compilation we mentioned before. Real multi-threading is something that is not quite there. You kind of have the notion of multi-threading, but it's not actual multi-threading at this point. I think lazy loading of application areas will be kind of cool, because I feel like that's a kind of weak spot even in frameworks like React and Vue. CSS isolation, so what that is if you're doing like a Vue component and you say that my CSS is, oh shoot, what's that keyword? Modular, no. Scoped. So those kind of scoped things, those don't exist in Blazor yet. And they want to do a little bit more involving the component structure. But we'll get more to that. Okay, so I mentioned before you need to have Core 3.1. This is wrong. You need Visual Studio 2019, 16.6. You don't need the Blazor language extensions from Visual Studio Marketplace. It's now built into Visual Studio. And this is no longer a command, but you'll see it in the upcoming slide. So let me show you a little bit of the cool stuff, then we'll jump into the hello world. So child content. One of the things that's kind of cool is that we can build a page and we can have a child component, which is defined down here. And inside that component we can have, this is just showing just a line of text, but it could be another component, it could be random HTML markup, etc. And that all happens by the virtue of having a child content property named child content, and it needs to be type render fragment. So it's kind of an implicit property of components, but if you put something inside of it, that's how you're going to be able to get to it. And then later you can render it how you need. So in this case, we've got a title and we got child content, so we're just going to render it in 2 divs. So kind of cool component nesting there. This is one of the places where it's changed a little bit, but this is a layout page. It's kind of like a master page. What we have is we inherit from something, and nowadays it's now layout component base instead of Blazor layout component. And that has a property called body that we render at some point, and you can have other things that we add. And then if a child component wants to change the copyright message, it can just write to it. But later on, you can say my layout is this master layout, because this is named master layout.razor, and we can go ahead and render our page. The need for this is also no longer, because the router will provide a default layout. So mostly in the demo you won't see this, but it does still work that way. Okay, so here's some more on JavaScript interrupt. So let's say we had a couple of JavaScript functions we want to call from our WebAssembly. And this probably wouldn't be exactly the way you do it, but so we've got this example functions. We've got a show prompt, which is going to just do this, or you've got a display welcome, which is going to change the DOM in some way. We're going to invoke something back in our method, and then say hello is another function where we're going to invoke say hello in our method. So let's see. We're returning something in this one, saying this one, this one. So here is the actual code, the C# code behind this. So for the prompt, we just do JS runtime current invoke async. We're going to get a string back from this, but all we do is give it the full name of the thing we want, and we then just pass in our parameters. So this is the example JS functions show prompt, and again prompt is going to return something, but we pass something in and we got something back. So that's how that works. Here we've got a display. So this display is going to call display welcome, which is this method here, and that's just going to take whatever welcome message we put in here and add it to the welcome div element. So same kind of thing, we just render it this way. I'm not sure exactly what the return is going to be on this, but yeah. Anyway, and then last one is call hello helper say hello. So we're looking for the say hello, which is this guy, and we're going to invoke him, and then we're going to return pass in as a parameter something else to do, and then that's what's going to happen over here, which I can't show you. But anyway, this is the kind of the basics of just kind of back and forth between JavaScript and C#. So the client-side hosting model is kind of the simplest to reason about. Basically, you've got the browser, you've got UI thread, we've got Blazor running inside of here, WebAssembly, and that's all there is to it. It runs just like JavaScript. You could cross this out and put JavaScript, and that's the way JavaScript runs, right? So it's pretty simple to reason about. A little bit more complicated to reason about is the server-side hosting model. What happens in this one is all that stuff that was happening in Blazor before is happening on the server side. Signal R is just kind of pushing the rendered content back to the browser. So this isn't using any WebAssembly on the browser, but the same kind of components can be created over here on the server side, and then the resulting DOM is then updated over here in the browser. Okay, so let's do a quick walkthrough. So I'm going to run these commands more or less exactly. So let's get a command prompt, and then let's do .NET new Blazor WASM minus output Blazor app 1. And because I have .NET Core 3.2.3 installed, that template is already there. I didn't have to install anything new. Didn't take this long the first time. Well, this is what happens when you do live demos. All right, well, we'll just go into this one. And then we're going to do .NET run. Okay, and we can see it's running here. So I'm just going to grab this URL here, and we'll open up a new browser. Paste that URL in. Okay, and here's our demo app. So let's walk through the demo app, and then I'll show you what's underneath it. Here's the home page, right? It's got a little survey thing here, which we'll look at. A little counter button, so as long as you click it, it'll increment that counter. Over here, we've got some data that was fetched and then displayed in a table. If we open up our dev tools here, F5 that, we'll see that our WebAssembly was 15K and the .NET Core JS was 57K. So altogether, really tiny payload, still a very small fraction of the size of Bootstrap min.css. And then down here, we're in debugging mode, so it's saying it's in memory using 6.8 megabytes of resources. However, when you do this in production mode, this goes drastically smaller. So just kind of FYI. I've not played around with this a ton, but it seems like it might be as much or more efficient than regular JavaScript. So it's kind of cool. So let's go see what's behind us. So if we're going to close this for now, and then over here I'm going to go Control-C and then code dot. All right, so the first thing I want to look at is program.cs. This is where everything starts happening. This is our main. You'll notice the async task main, and that's because we're using a kind of modern dialect of C# that you can do that. We create a builder. This is going to tell us that our app is going to be loaded in a tag named app, which you'll see next. Here we're registering our services. In this case, we only have one dependency registration, which is our HTTP client. And after that, we just tell it to build and run async. So next, let's go look at index.html. This is also pretty simple. This is the app that we're talking about when we say this is where we want to load our app. So I don't know, you probably didn't see it because it kind of flashed for just a microsecond, but it said loading before everything got loaded and the app loaded into space instead. The only thing we need to reference here is that Blazor Webassembly, this is our WebAssembly, and then everything else is just regular JavaScript stuff. Any questions so far? I'll take that as a no. Okay, so next let's look at app.razor. So if you'll remember, we told it that in the app tag we wanted to load app the class. So this is app the class. Because it's named app.razor, it's kind of implicitly has a class name. I think they probably want to cut down on the places where you need to do actual C# code, just kind of make it more simple. So this is app.cs is the way you can think of this class app. What we're doing in here is this. We've got the main router. We've got the found. We have a found route, and we've got the not found route. And if we have a found route, then we have a route view that's going to load whatever it is we need to load here. The default layout here is what I was talking about. You know how I was saying that you no longer have to put the layout tag in your pages. because it'll just provide a default layout. That's how this is wired up. And the route data is basically just looking for the page that matches here. So for example, if we look at index.razor, that's what it's matching on. So this is the page that matches /, and so this is what loads initially in that route. So while we're here, you'll notice we have this survey prompt. This isn't a standard HTML thing. It's kind of in red here in code, so it kind of gives us an idea of what this is a component. So this component is actually found in the shared survey prompt. Look how we have a title where we're passing data in here. On this Razor, we have a parameter property marked with parameter, whose name is title. So that's where that's how that code gets passed from one to the other. And all we do is look to see where title is being bound. You can see something that looks akin to Razor syntax binding that title here, and so that's how that works. Just for a moment, let's go look at main layout.razor. So in here we've got a nav menu component, which is down here, and we've got this app body. So this app body is where our pages actually render into. So when we look at this index, all of this stuff renders into this spot right here. So it does kind of work like a master page, if you're familiar with those. But let's look at something a little more interesting. Let's go look at that counter example. So we can see we get this page with the /counter. We've got some plain HTML for the content. Here we've got a binding to something called current count, which we find down here in our class code. Got current count equals 0. And then for the first time we're binding an action. So we've got this at onClick equals increment count. So that's how this is being bound. So the onClick of that button is being bound to this increment count. All we're doing is incrementing this value, and the rebind automatically happens. So it's kind of very simple. We don't have to worry about observables. We don't have to worry about rebinding. We don't have to worry about unidirectional, one directional. We don't have to worry about reducers. We don't have to worry about any of that stuff. It just kind of works, which is kind of cool. Any questions on this? Okay, so let's do a little bit more sophisticated here. This is the fetch data that it generates. So we can see we're in the fetch data page. This is where we get our dependency injection. So this is the type, and then this is what our local variable is going to be called. Again, that matches with how it was defined. We told it we wanted to add a transient for this type. So with that gets that gets automatically included in here, and it's kind of automatically accessed as kind of a implicit property. You see, we don't have to put it as a property down here or anything like that. It just kind of exists. And this one's kind of cool. So what we're doing here is we've kind of got a conditional bind. If forecast equals null, e.g. we haven't downloaded the data yet, then what we want to do is just display kind of a loading text, right? Otherwise, we want to actually display the data. So here's the data, which makes sense because we probably won't have anything to show if we haven't loaded it yet. This forecast is an array of weather forecasts, so it's kind of really powerful binding syntax that we can change that DOM that drastically. Anyway, in here it's got a regular table, and we're just for eaching on these table rows, and then just really basic regular Razor binding syntax for these values. And then something else that's new here is we've got this override on initialized async. So these components have the same kind of life cycle as a web component would. So there's a lot of other things that you can override. I wonder if actually if it will give me a list. No, I bet if I was in actual Visual Studio it would give me a list, but I'm just in code. But you should be able to see all of the things that you can override for your life cycle of this. And this one's really simple. We're just grabbing into a weather forecast array at this endpoint. That endpoint is just a JSON file. So if we look over here to our www root sample data, here's our JSON file coming in. I will also point out this is kind of a newer library, this HTTP client with the support for JSON async. It's really well suited for jobs like this. So I think that's one of the reasons they wanted to showcase it in here. And then a weather forecast is just this object here. This does not have to appear inside your Razor file. It can be in its own class as part of the project. It can be as an assembly outside of this project. It can be anywhere. But for sake of simplicity, they're just displaying it here. And then just kind of showboating with the conversion from Celsius to Fahrenheit. Okay, so any questions on this so far? Okay.
Looks awesome.
Yeah, it looks very cool.
I don't have a server rendered example ready. I did when I presented this before, so that's why it's in here. But there it is. I was also going to do a demo of how does Blazor compare versus JavaScript and speed. I no longer have to do that. Someone else already kind of scooped me to it. It's way faster, especially if you are doing kind of just basic stuff. Because JavaScript is kind of a typeless and C# is typed, it kind of has an advantage. So it's kind of an unfair advantage. But yeah, WebAssembly C# wipes the floor with JavaScript. And then here's some references. In parting, I think this might be, I think what we'll probably do is the next smaller project that comes along, we'll probably use this as the front end for it. You know, next one that makes sense. Make sure there's no kind of big hiccups or anything, but I fully anticipate that most of the front end we do from here on out is going to be Blazor. Sans any kind of type or framework requests from clients, or maybe there's an existing code base that's already written to something else. If this is a kind of a greenfield thing, I don't see any reason not to just kind of start using it and get a little experience with it and make sure that we don't have any big problems. Like I said, it might be a little bit of time before I'm comfortable using it with a bigger project. I want to get a couple of small and medium-sized ones kind of worked through. But yeah, I think this could be a stack that we can use as our default going forward. So yeah, any questions, comments?
I pasted the override in the lunch channel there. If you want to see what it's allowing you to see.
The override? What do you mean?
When you try to get the override options for the...
Oh, cool. Yeah, totally. Let's see if I can find that.
And I started my app just by going to new project and clicking on Blazor, and I got the exact same thing they did.
Yeah, I was following the more... actually, my Visual Studio isn't up to date yet, so...
Oh, I see.
Yeah, there's all the events. Nice catch or ad. Thanks. Another thing I could show is some of the components that were available. That was kind of interesting. Let's see. So, I mean, these are pretty cool, but I'm really shy of using these based on some experience in the past. These are also cool, though. This one was interesting in that I wasn't quite sure. I mean, everything in here is basically... Well, the website itself isn't all that well done. But the examples and stuff look so simplistic that I'm like, why not just, I don't understand what you're adding here. Input's a good example. So I want to see the code for the input. Why am I using an ant text box? It's just a text box. I don't see a need to do that, but maybe I'm missing the point. I mean, some of these more advanced things like a carousel, okay, that might be useful, but this is the only one that I kind of looked at and I'm like, oh, I'm not that impressed. These other ones though, looks kind of interesting. So this is material design for Blazor. And it's pretty simple stuff. But even beyond that, there's more put together components. So in this one, for example, let's see in action. There's actually some things that are kind of more interesting, like there's forms and validators that are a little bit more interesting. My only complaint about this one is I really like to be able to, okay, I see this example and then like click a button to see the code behind it. And they don't really have anything like that. They just have a documentation button where then you can go and look up the same thing, you know. So I think this website could be a little better, but I think in general, the components are pretty at least useful. Let's see. Anyone else want to see anything else? Oh, do you want me to show you that that link for? Let's see. Where's my operating system? And does that still work? Here goes something. The point of showing this demo in the original was just basically, well, if it's sandboxed, is it going to be useful? And I'm like, well, there's quite a lot you can do in a sandbox. But yeah, this is a Windows 2000 running inside of WebAssembly. And it actually works. So I do this in my demo, but I pull up, the browser takes forever to come up, but Putty is in here or something like that. Yeah. And you can totally SSH into a remote system.
Pretty cool.
Yeah. It's more of a gee whiz thing, but it is kind of neat. All right, anything else anyone would like to see? I'll paste that in Slack. If anyone wants to, if no one believes me about it. All right, well, I finished in about 45 minutes, which is exactly what I planned. So thanks for attending, guys. Appreciate it.
Thank you, sir.
Yeah, thanks, that was great.
Who wants to go next week? Remember, you're all muted, so you'll have to unmute to say me, me, me. All right, well, I guess I'll find someone, or I'll do another one next week. So, any requests for topics?
Does anybody feel up to doing a Caliburn Micro demo?
So the thing of Caliburn Micro is we're actually going to be moving away from that a little bit on future projects.
Yay!
Caliburn Micro is really cool though, so don't celebrate too much. Any other requests? All right. Well, talk to you guys later.
Later. Thanks, Hank.
Thanks.
Bye.